In this video, I am going to define moments and then I'll do an example. Let's let n be a positive integer here. Then the nth moment of x is defined by the expectation of x to the n. And if x is a discrete random variable, then the expectation of x to the n is the summation x to the n times p of x, where the sum goes over all values of x. There is another notation for the nth moment, which is mu subscript n. So mu subscript n also denotes the nth moment of x. Let's do an example. Seems like my OneNote is stuck, so I'm going to pause for a second. Alright, so let's let I be the indicator variable for an event A. That is, A is some event, and the variable I is defined as follows. I is 1 if A occurs, and I is 0 if A doesn't occur. So that means A complement occurs. So what's the expectation of I? The expectation of I is well, there are two values of I, so I multiply each value of I by its probability. So 0 times the probability that I is 0 plus 1 times the probability that I is 1. The probability that I is 0 means the same as the probability of A complement, and the probability that I is 1 is the same as the probability of A. So the expectation of I is equal to the probability of A. The last example that I want to make a remark here, which is the following. Remember that if x is a discrete random variable, then the values of x can be viewed as a list. So on the number line, imagine that you have the list of values of x. Now imagine that at each value of x you have a weight hanging, where the weight is equal to the probability of that value. So at x1 you have a weight hanging, w1, which is the probability of x1. At x2 you have a weight hanging, which is equal to p of x2, and so on. At xi you have a weight hanging which is equal to p of xi. At xn you have a weight hanging which is equal to p of xn. Then the expectation of x is the location, which is the center of gravity for these weights. That is, the expectation of x is the point where these weights will hang in balance. Okay, so this is it, and I'll see you in the next video.